This video will introduce the basics of non-targeted analysis, or NTA, and explain its uses and limitations. The United States Environmental Protection Agency uses measurements of chemicals to monitor human and ecological exposures, characterize health risks, and ensure compliance under federal statutes. Traditionally, chemical measurement data have been generated using targeted analytical methods, which are often based on low-resolution mass spectrometry and always optimized to focus on limited pre-selected analytes. Unfortunately, these targeted methods are largely blinded to all other chemicals that are present in a sample. As such, emerging contaminants may go undetected if EPA relies solely on targeted methods. Using high-resolution mass spectrometry and a new analytical technique called NTA, emerging contaminants can now be identified without pre-selection in any sample of interest. When conducting an NTA experiment, acquired data for each chemical comprises its chemical signature, or fingerprint. Hundreds to thousands of chemical fingerprints can be observed in a given sample. These fingerprints can be prioritized for further examination using various criteria, including presence or absence in control samples. To support chemical identifications, prioritized fingerprints from NTA experiments can be compared to cataloged fingerprints of known chemicals. Oftentimes, there are numerous fingerprint matches, and multiple chemical candidates must be further examined. Chemical metadata can be used to further prioritize chemical candidates with similar fingerprints. Some metadata, such as chemical use information, are used to select candidates that are most likely correct. Other metadata, such as hazard information, are used to prioritize candidates that may pose the greatest health risks. If a prioritized fingerprint from an NTA experiment does not match any cataloged fingerprints of known chemicals, researchers can manually inspect the experimental data and use expert judgment to propose a chemical structure. Whether identified through fingerprint matching or expert judgment, each chemical structure can only be confirmed as correct by comparing experimental data from a study sample against that from a reference standard if available. When a reference standard is unavailable for chemical confirmation, researchers must take great care in reporting the level of confidence associated with their findings. Thankfully, the scientific community has developed guidance to aid the reporting and interpretation of chemical identifications from NTA studies. For a given NTA experiment, not every observed fingerprint can be assigned a chemical structure. Additionally, not all chemicals that are truly present in a sample can be observed as a fingerprint. This is because each analytical step, from sample preparation to eventual chemical detection, narrows the detectable chemical space. Thus, while an overarching goal of NTA may be to detect every chemical in a sample, different types of instruments are needed to detect different chemical classes. EPA researchers are developing tools to better understand which chemicals are detectable by certain NTA methods. A fundamental advantage of NTA methods over traditional targeted methods is the ability to rapidly identify chemicals that may be emerging contaminants. Despite this advantage, it is important to remember that chemical identification alone does not equate to risk. Risk can only be assessed given additional quantitative information related to chemical exposure and toxicity. It is expected that new quantitative NTA techniques and bioactivity screening procedures may soon facilitate provisional risk evaluation of chemicals detected in NTA experiments. Development, refinement, and demonstration of these quantitative procedures are underway in EPA labs. Targeted and NTA methods go hand in hand. Targeted methods will always be the gold standard for quantifying known chemicals in selected samples. But NTA methods facilitate more comprehensive chemical characterization and the identification of emerging contaminants. NTA, therefore, represents a fundamental shift in the capability to detect underlying public health threats related to chemical exposures. Whether used alone or alongside targeted methods, NTA improves the EPA's ability to protect human health and the environment by better prioritizing exposure and hazard research.